Oh, welcome to my talk. Let's talk about automating my home office. So I work remote, so my office is something that is very important to me. This is what it looks like. And because I work remote, I really like to have everything set up just the way that I want, in a way that works well for me and that works well for all of my meetings. My office is a small nook that I have in my house. There is around a 6-foot partition wall with some LED lights on top of it for some mood lighting, and it has a standing desk, and it is ready for some automation. But first, a little bit about me. I've been developing in Elixir since 2016. I am a senior software engineer at Felt, and I am a member of the Scenic core team, and I help maintain many different libraries in the Elixir ecosystem, and I've contributed to many more. The agenda for today is we'll talk a little bit about exposition, about how we got here, talk about the casting characters for my automation on the main stage, the automations themselves, and then we'll finish up with some reflections. So, how did we get here? Well, rewind the clock back to 2018 when I attended my very first Elixir Conf. That was in Bellevue, Washington, and as part of the conference, I attended the Nerves training, which was a great training, and as part of that, I received a Raspberry Pi 3B Plus and an official Raspberry Pi 7-inch touchscreen. That was also the year that Scenic was released, which is, Scenic is a graphical library for Elixir. That's really cool, and I use it in this talk and in this project. Fast forwarding to 2021, I attended another Elixir Conf, this time in Austin, and this is when I gave my very first Elixir conference presentation, which was titled My Scenic Companion. And in it, I talk about how I have that same Raspberry Pi on my desk with the touchscreen in a nice prominent position, and I can run my own software on it, written in Scenic, and interact with it. At that time, it had 3 main pieces of functionality. It had a Govy LED light, which I connect to over Bluetooth, and this is you can see the Scenic interface in the bottom here. And I would use this to indicate to my coworker, which is also known as my wife, when I was in a meeting or not, because it wasn't always obvious. The second functionality is a Pandora interface for my music. It would show my music and allow me to control it. And the third is my own Pomodoro interface that I wrote to show, or to like track my focused work session, so I know when I was working and then when I was taking a break. Moving forward onto 2023, I gave another talk at ElixirConf, this time about drawing with a 7-color e-ink screen using Scenic and Nerves. This is what the screen looked like. It had a few different pieces of functionality. On the left, it had information about my coworkers. I had what the weather was for them, their location, also what time, because they are spread out all across the globe, and information about their GitHub PRs. There were quotes of the day, calendar, and time, and my favorite functionality was this Pomodoro visualization at the bottom that would show when I was working throughout the day, because I found that if I work for too long of a stretch without taking a break, it impacts my mood and productivity. So, it's been a few years since 2021. 2023, what has happened since then? Well, I've been continuing to maintain and improve different parts of my setup, some more than others. My e-ink screen is now, unfortunately, neglected and dead. And one of the main reasons for that is because, at least with the current technology for 7-color e-ink screens that I have, the display refresh rate is really, really slow. It takes like over 30 seconds, so half a minute. So with that, I could only update it every 30 seconds, or once every 30 minutes, and it would flash and be a little bit distracting. But the software lives on. I still run that on my desktop, although honestly, mainly at this point, it's just for that Pomodoro visualization. But I've been continuing to use my Scenic Companion pretty much every day since 2021. And it's also even learned a few minor things like some calendar functionality, so I can see when my next event is. I've also changed my monitor setup and added a bunch of hardware that is ready for some automation. So what is the hardware that we're looking at here? Well, I break my hardware down into 2 main buckets. I have my computer-ish kind of standard things, and those are, I have my primary and a secondary monitor. I have 2 laptops that share a single dock so that they can have a stable IP address and hardware peripherals. I have my personal desktop computers. I have a keyboard and mouse. I have a USB switcher that I use to switch the input for my USBs between the dock and the desktop. And I have a USB microphone so that people can hear me very well on meetings. On the hardware side, I have my key light, which is my meeting light, so that I can look as good as possible on my meetings. I also have Govy LEDs and LED strips to provide some mood lighting because I also use my office space in the evening and I want to be able to relax. And I found that actually changing the physical lighting helps with that. I also have office lights that I can control and around the house. I have my macro keypad, which I'll talk about today. And I also have a standing desk. So let's look at what those look like in my space. I have the USB switcher kind of hidden in the back. I have a main monitor that I'm switching between my laptop and my desktop right in front of me. I have the secondary monitor that's always showing my desktop below. I like it better below than above because I don't want to kind of crane my head and I feel like it hurts my neck. My laptop's on the left. I have the USB microphone on the left on a swivel mount, so when I have meetings, I can swivel it out in front of me, but otherwise it's kind of tucked out of the way. And I have my keyboard and mouse over here. And my desktop is in the closet to the side of me, so it's not in this picture. And then I have my laptop dock, which is actually kind of behind the monitors. Moving over to the hardware side, I have my Govy LED strip on the top of that 6-foot partition wall. And the Govy LED light is behind my laptop. I have my key light on the right side here. I actually have it facing up because I like how that lighting looks better. I found if I point it directly at me, it ends up kind of, I look very shiny, and I don't like that. My ink screen is still sitting and chilling in the corner. I'm too sentimental to get rid of it just yet. But I do have my Scenic companion on the left here, very prominent and very easy for me to reach. And I also have a Raspberry Pi 02W on the right side with this breadboard, and it is in progress. And I have my macro keyboard to the left of my main Ergodox keyboard, where it is easily reachable and pressable. This is kind of how everything fits together and talks to each other. I'm not going to walk through it, but the main thing to point out is all these yellow pieces are all my bits of hardware that I've automated, and the Raspberry Pi for my Scenic companion sits in the center of all of it. Okay, let's get to the automations already. So who here has a light that they use for their online meetings? Okay, a couple people. And among you, who has to actually physically reach up, maybe stretch a little bit to actually turn their light on before every meeting? Okay, well, let's fix that. So I have a Elgato key light, and one of the reasons that I chose it is because it has a REST API that we can use. And there's actually already an existing HTTP library written by Lars, so thank you, Lars. But I can't run Elixir code directly inside myself, so obviously I need to have some way to control it. So for that, I use my macro keypad. And the reason I like this is because it's connected to my Raspberry Pi, so it's always on and always ready. The buttons are easier to press. I can build up some muscle memory without having to actually really look at what I'm pressing on the touchscreen. And I really like how it sounds. And I know when I press the button and when I haven't. The way it is hooked up is really nice and simple. It has a little 2.4 gigahertz USB dongle, similar to like a Logitech mouse or keyboard, and that just hooks right up into the USB port of the Raspberry Pi. I can read it with a little gen server that I put inside my Scenic supervision tree. There's a few pieces, so when it boots up, it uses the input event library from Nerves to look at all the input devices, and it looks for the one that says Mozart Semi 2.4 gigahertz keyboard mouse, which is this specific device, and then it captures that input and grabs it so that any key presses go to this process and don't go to any other process like my other Scenic programs running on here. And whenever a key is pressed, this function head will be called. It'll pass the key that's been pressed and one there just in case a key down. I don't care about key up just yet. And I can handle that key with whatever Elixir code that I want. So for controlling the key light, it's pretty simple. I press the button on the macro keypad, and then in Elixir, I build up a list of key light devices, which is just the one. The library does support discovery via MDNS, but I found over time that isn't always very reliable. So instead, I just give that my USB microphone or USB key light a specific IP address via DHCP reservation, and then I can just build it up by IP and call keylight.on, and it turns on. So it starts by pressing a button on my keypad, and then the light turns on, press it again, turns off, and so on. It's nice, quick, responsive, and it works. So I have a problem. Actually, I have many, but let's focus on this one for now. So I have one main monitor, but there's two computers hooked up to it. Typically, how you would change the input on such a monitor is by pressing these tiny little buttons, and I swear they're getting smaller and more even almost painful over time. And because I want to keep my monitors as close together as possible, I can't actually physically reach these buttons without moving the monitor out of the way. And I don't like friction in my work, so let's fix that. So on my macro keypad, I have two buttons to change the inputs. The one on the left will change the input to my laptop. The one on the right will change it to my desktop. And the way that works is it's using a library called ddcutil to change the monitor settings, basically virtually pressing those same buttons by sending DDC commands over I2C over the existing display port or HDMI port that you have. And you can also use this to do things like change the brightness of the monitor if you want. And of course, it's all without pressing a button on the physical monitor itself. But ddcutil needs to run on something that is attached to the monitor. So my desktop is attached to the monitor, but my Raspberry Pi is not. So I need to get the signal from my Raspberry Pi to the desktop. And the way that works is first I press the button on my macro keypad. Then in the Scenic Elixir library running on the Pi, it detects that, and then I use SSH to actually run a command on the desktop. And then on the desktop, we run that specific ddcutil command that will pass these specific arguments to change the input to the specific input that I want. But let's zoom in on the SSH portion, because I think that's interesting. So if you didn't know, Erlang has a built-in SSH module, and that is what I use to send these SSH commands. In order for that to work, you need to generate a public-private key pair and have that trust established on both sides. So on the Pi, I have the private key, and then on the desktop, I have the public key. And you put the public key in your authorized keys file, and the main thing is you have the key algorithm and then the actual key. But as a prefix to that, for this case, you can put a command. And that means that rather than allowing this key to run any command on your computer, only that single command can be run, which is good for security. And of course, I don't want to have a separate key for every single automation I have, so I just have one script that can receive multiple different commands, do some light parsing, and then shells out to other shell scripts that I have. I like having those other shell scripts so that if I want, I can run them locally from that computer without having to call this larger script. So putting it all together, I press a button on my macro keypad, and then the monitor will change. And then I press the other button to switch the input back to my laptop, and after a couple seconds, it will change again. Nice and simple. So wait, what about all those wires that you had in that Raspberry Pi Zero? Tell me about those. Well, that is for controlling my standing desk with Nerves. This is my latest automation. So I have a fully brand Jarvis standing desk. I think a couple of you may have something similar. And it comes with a handset interface that is a touchscreen, and it works, but it is a little bit finicky, and sometimes it goes to sleep, and you have to press a button to wake it up, and to press another button to then change the position. So that's a little bit friction and frustrating, so let's improve it. So there's two main pieces to the fully standing desk that are of interest here. There is that handset interface, where you can control it, and then there's the desk controller, which is what actually moves the motors itself. And they talk over this Ethernet cable that has an RJ45 jack. But very importantly, the signals on this Ethernet cable are not actually Ethernet. When you look at it, Ethernet cables are just wires, or a bundle of wires. So you have the 8 pins, and they're connected on one side, and the same 8 pins matching those same colors are connected on the other side. So this is what it looks like in a close-up. I took the Ethernet cord that you can see on the right, and I stripped it all off, and I connected like Waco connectors. This is partly because I didn't want to wait for shipping of an actual Ethernet breakout, which would look a lot cleaner than this, but this was faster. It's all hooked up to my Raspberry Pi Zero, and for the specific, well, through the breadboard. And for the specific pins, there's a great resource put out by Phil Hord that has reverse engineering instructions for the desk. Here's those 8 pins of the Ethernet connector and what they all do. I'll walk you through them. There is ground and voltage, which is straightforward. There's also these handset control lines. And if you bring down any of these handset control lines, you can move the desk to one of the preset positions, very simply just by pulling it down to 0 volts. There's also these DTX and HTX pins, which are serial pins that can be used to send serial UART messages. Okay, so let's hook it up. So first, we'll hook up the ground on the pin to the pin 3 ground to the ground on the Raspberry Pi. Next, we'll hook up the handset control lines. And these can go to any GPIO that you have available. It doesn't really matter as long as you remember which one you connected to which pin. And then for the DTX and HTX, so starting with the DTX, this is for sending the messages from the desk controller to the handset interface. And so we hook that up to the UART receiving line on the Raspberry Pi so that when messages are sent from the desk controller, they are received by the Pi. And then on the opposite, we have the HTX, which is for sending messages from the handset to the handset interface to the desk controller. And that gets hooked up to the TX line on the Raspberry Pi. So messages sent from the Pi are received on the desk controller. OK, let's give it a try. So as our first experiment, we want to move the desk up. And to do that, based on the instructions, we find the up column. And we say, OK, we need to bring the HS1 line down to 0 volts. So let's do that. We can use the circuits GPIO to do that, where I've connected GPIO 5, set it to output mode, set the pull down mode, or set the pull mode to pull down the voltage, and we do a GPIO.write to actually bring that voltage to 0. So I did all that, and then nothing happened. And that was very sad. And I had spent all this time stripping wires that day, and it was getting late, and so I went to sleep sad that night. But luckily, there was another day. I woke up and I thought, OK, I haven't exhausted all my options. Let's try the UART. So UART is the other way to control this desk. Rather than pulling the lines low, which is the simplest way, so that's what I tried to start with, instead you send messages over 9600 bits per second, 8 data bits with no parity. And you can do that with the Nerves library circuits.uart. So you start your UART process, and then you open the specific PID that you want. TTY AMA 0 is the name of the UART controller on the Raspberry Pi 0W, and we set the speed and octave false, which is pretty much the default you want these days. And Elixir and Erlang have really great binary pattern matching, and it makes it really easy to read and write these sorts of protocols. And the way the protocol works for the Jarvis is pretty nice and elegant with some good checksumming and redundancy built in. So the first line here is getting the command byte, so it's just a mapping of atom to the actual command, which is just a number or a byte. And then we're building the actual binary with these less than and greater than signs. And you pass the address that you're sending from, so in this case, the handset interface. And you pass that twice, just as I built a bit of redundancy. And then after that, you pass the specific command bytes that you have, and you pass the byte size of the params, because that can vary from 0 bytes to 3 bytes. And you pass the params themselves, which could be multiple bytes, which is why it's binary there. Everything else here is a single byte. And the second to last thing is the checksum, which you're just combining, adding up the command bytes and the params, and then doing a modulo 255. And the last message, or last byte, is an end of message, which is always the same 0x7e byte. Once you have that built up as a binary, you can send it directly to circuits.uart.write and give it the message. And then you get a response back from the desk. The format is pretty similar, but this time you're getting the messages coming from the desk. Height response is just a macro that maps to the integer 1, which is the height command. And then you have the height as 2-bit, which is 16, or 2-byte, which is 16 bits. And we don't know what that third byte is. I'm ignoring the checksum for now because I just want to verify that this works. And similarly, the height is actually coming back in inches, but there's actually a meters mode, which I'm not using meters. And if I move to Europe, maybe I'll switch my software. OK, and then similarly to my monitor, I need to get this command over to my Raspberry Pi 0W from my main Raspberry Pi. And the way I do that is just by setting up clustering between them, and I use an RPC call to invoke the function remotely. Okay, so let's see it actually work. So I press a button on my keypad, and then my desk starts raising. And this felt really nice the very first time it happened. But more than that, if you saw in the video, this is my start meeting button. So it actually does more than just raising the desk. It also turns on my key light and stops my music. And then when I press the button again, the light turns off and the desk lowers, and I can get back down to my heads down mode. I do want to improve this wiring. I don't want to keep it on the breadboard forever. Instead, I want it to be like a pass-through where I can have that handset interface still active. And instead, the Raspberry Pi will be kind of like tapping off these lines. So both the handset interface and the Raspberry Pi can both be on these, and they'll just ignore the messages that are not addressed to them. And my inspiration for that is from this YouTube video by David Zhang about him automating his office. And this is how his setup looks like, where he has an Ethernet pass-through with a little 3D printed case. And you hook up one side of the Ethernet controller to the handset interface and the other to the desk controller. OK, it's time to wrap up. So there's some other fun things that I've done that I didn't get a chance to talk to today. One of them that I really like is that whenever I start one of my Pomodoros or finish one, I actually add a line to my daily Obsidian note. And that's an indicator to me to write down a little blurb about what I was working on in that work session. I can also control the lights in my house through Lutron smart switches, and that has an interface with Home Assistant. So I have a little Scenic app that talks to Home Assistant via its REST API as well as its WebSocket to control my home lights through Nerves. And I have buttons to advance my Pomodoro. That's actually probably the one I use the most. I have a button on my keypad to turn off all of my devices. I have some web interfaces from my Pomodoro that run on my Raspberry Pi. And I can even access my Phoenix apps remotely that are running on my Pi through my server and with like a caddy reverse proxy. And I have a single Phoenix app that I use to provide one single unified login to all of my Phoenix apps. And we didn't even get to talk about all the wires that I have. I have a lot of wires. I like wires over wireless because they're more reliable for me. And yes, I do actually have 2 pairs of headphones. I have a few reflections to close up with. Software requires a lot of loving care to avoid bit rot. You don't want the same thing happening to your e-ink screens. But also, developing your own software and using it daily is very rewarding. You know the audience, it's you, so you know exactly what you want generally. And I really love that I've been using my own software for 5 years every day. Every time I use it, I get a little spark of joy. And it's also really fun when you can press a button and software that you wrote runs, and you can actually physically feel your desk rising in the air. Here's all my repositories. Everything is open source. And a big thank you to all the maintainers of the libraries I use, especially the Nerves core team, and Phil Hord, who created that reverse engineering info, and David Zhang for his inspirational automation video. So I hope I've inspired you to automate your offices as well. Thank you.